So, hello everybody. Thank you for inviting me here today. We had quite some interesting presentations so far, mainly related to the municipality and the city green transitions. I come from the chemical company located in Czechia. So I will be presenting the case of, let's say, a middle-sized chemical company, a little bit about the history, and a little bit about current situation and the future related to the renewable ideas and green transition in this specific case. So location, yeah, as you already know, we are in the middle of the forest. And this plant location, like any other plant location in Estonia, in Pärnu, you always have to look the local environment when you're thinking about developing the strategies for the green transition. And of course, we are in the middle of the big forest, and this is actually giving us specific opportunities for the development, the energy transition. On the company. Of course, we have Natura 2000, big protection areas, so you have to respect that as well. Just a little bit about the general information of the company. The company was established 70 years ago, actually, 1954, city. The turnover now is roughly 50 million euro. We have production of different materials. So main production is synthetic polymers, mainly used in coatings, tar industry, textile, construction. So we have about 200 different products. We also have paper industry, impregnated paper industry for the chipboard industry, and we have impregnated textile industry for the shoe industry manufacturing. At the moment, we have around about 190 to 200 people, and the company has always had a very strong research and development team. So there is about 12% of employees, so about 25, it can be also up to 30 people working only in the R&D development. The company is actually selling products globally. The export now, I think it's over 85%, and we are selling to over 50 states worldwide. As I said, our main markets are for the chemical industry are coating markets, especially can coating. If you drink beer from the can, or if you drink Coca-Cola or whatever, you will have in your hand our products. We are very strong in the rubber industry. I think about 70% of car tires in Europe are made with our materials, manufactured here in Chile. Also very strong in paper industries for various paper mills around about Europe. And construction industry, where we produce additives for concrete and other additives for the construction industry. For the wood industry, as I said, we manufacture decorative paper impregnation. This is what your furniture is made of. Surface materials on the furniture and textile industry, impregnation materials. So markets, as you see, are global. The main is Western Europe. So this is our main market, but we also sell to the United States, to South America, Africa. So practically all continents. And about the history of the company. So the company actually was built in 1954 here in Kučevo for two reasons. The first reason was the infrastructure that was actually here from the previous textile industry that was operated anymore. And the second reason was coal. So the lake that you see in Kučevo is actually what is left from the mining of the coal location. So the energy source was here. The type of polymers Melamin was producing already in 1954 were known to be energy quite intensive processes. So they always have to look for the potential energy resources, mainly heat, but also electrical power, but mainly the main energy resource was always the heat. So the company actually was built, and it was using coal until the year 1968, where the coal mine in Kučevje was stopped. So there was no more coal production. And of course, in that time, everything was moving to oil. At that time, we had 2 oil refineries locally, one in Rijeka, now in Croatia, another Osijek, so now in Croatia. And the company started to use oil as the main energy source in 1968, and this is going on until 2014. Of course, in the 2014, most of the oil was bought because Slovenia has no oil refinery. And at that time, Slovenia bought most of the oil from Russia. And at that time, Melamin was paying 2, maybe even 3 euro per year to buy Russian oil. And in 2010, we started to think about the future, what to do, how to get greener, how to do the decarbonization of the energy source. And we looked around, and we have realized that we have a lot of wood biomass of very low quality that cannot be used for furniture, paper, or any other use. And that this might be a very interesting energy source for the chemical plant. Of course, a lot of the wood chips at that time was really low quality in terms of extremely high humidity, up to 60, also 65%, also the green wood chips. And we have decided, since at that time the municipality already had the power plant for district heating system of the town Kučevje running on the wood chips, but they used the technology that required very dry chips, I think up to 35, 40% humidity. And we didn't want to go into the competition on the market to buy wood chips, same wood chips as the municipality is buying. And we said, no, we don't want to do that. We are interested in the humid wood chips, like green residues that cannot be used for the municipality heating, so that we have no competition on the market. It took quite some time to find the proper technology. And at that time, this technology was not really developed yet to the scale that was needed for the chemical plant to operate it. So actually, we were quite enthusiastic about it. We made a team of international experts and decided to develop bubbling fluid bed technology for the size fitted for the chemical plant. This was actually the first 10 megawatt power plant running on bubbling fluid bed technology, which was started in 2014. At that time, I was already at the company. People were saying, you're crazy. Are you doing this? You have gas, you have oil, you will not be able to get chips, and these wood chips are too expensive, and so on. But it was our feeling that this was the right thing to do. This was way before the Green Deal. And the starts at that time were really difficult. It was really difficult to get wood chips because there were no local support to get the wood chips. And at that time, all the forest in Slovenia was managed by private companies that had their own way of doing business. And we could not get any deals to get wood chips from them. So what we had to do actually for the year 2014, we had to make a deal with the Croatian state company, and we wrote a contract for the first year of delivery for the wood chips in Kučevje, full of wood chips from Croatia. Which is crazy. But we did it, actually, we did it. And slowly, year after year, we helped develop local suppliers, like farmers and small businesses, to open up the doors. And we set up the strategy to buy wood chips from any supplier, local supplier, within, let's say, about 20, 30 kilometers range, at the same price. So it doesn't really matter who is supplying wood chips. Everybody is getting paid the same money, so that we are actually preventing reselling and channeling of materials. Since 2014, I just checked today, over 10,000 trucks of wood chips were brought to Melamin. Melamin is the second biggest consumer of wood chips in Slovenia after Energetika Ljubljana. They are about twice our size. And roughly speaking, in these 10 years, we have paid to the local suppliers within the 20-30 kilometers range around about 15 million euro for wood chip supply. So this was actually direct implication for this decision. I think very big for the local economies, and the local suppliers actually in the last 10 years developed storages, technologies, millings, a lot of infrastructure and logistics, so that today actually supplying wood chips from the local area is really no problem, because we have at the moment I think 28 or 29 contract suppliers from the local area, plus we have about 20 that can occasionally supply without contract. So we are dealing with roughly 40, maybe even 50 different suppliers locally. So the wood biomass decision actually reduced the carbon emission from the company for more than 95%, which was over 10,000 tons of CO2 per year, which is a lot. And in this way, actually, Melamin made the green transition practically 95% in 2014. This was way long ago. And in 2020, we decided to upgrade this energy system by installing the cogeneration for heat and power. So we have installed a counter-pressure steam turbine to actually get electric power also from the system, from the wood chips. Which is running 24/7 in the day and in the night, supplying electricity around the day, also in the winter and in the summer. And it's covering at the moment around about 20% of the electrical energy needs of the company, and 80% at the moment we are still buying from the grid. But this 80% we will replace by solar panels that we are starting installing this year. We will install solar panels in different stages. Probably this year and next year we are installing 1 megawatt. We are now preparing a project for another 2 megawatt, and we are thinking about the third stage of about 20 megawatt. So this is actually a 3-stage process that will continue over the next years. Very important for green transition is not only to use renewable energy resources, but to use resources very effectively. And at high efficiency. This is really important. This is why the company has developed all the necessary technologies to operate the principle of zero waste technology. So everything, what is a side stream of the manufacturing, is being recycled within the company back to the raw materials and reused back into the raw materials. So actually, the company is operating practically without any waste, except some waste that comes from the cleaning of the equipment, which goes to the wastewater treatment plant, and waste gas cleaning, which is typical for the chemical industry, where we need a thermal oxidation to basically recycling loop. So the biomass boiler and the cogeneration, as I said, it's a bubbling fluid bed technology. I don't know if you're familiar with it. So this is not very common technology for wood chips burning. It is mainly used in the most advanced incinerating plants in the world. It actually works in a way that you have a quartz sand. So you have a sand pool, which is heated up to about 800 degrees. And you have nozzles that are bringing recycling, flue gas, and oxygen from the air and make the sand bubbling. And on this bubbling sand, you are actually dropping wood chips, where the wood chips are heated up and the wood is gasified without sufficient oxygen to really go into the burning. So there is no burning actually in the technology inside, but you have gasification. And then these gases are going up because they are hot, And then you have an, let's say, reactor, which is multi-stage oxidation reactor, when you are bringing just the right amount of oxygen in each stage, so that you actually can control the temperature of the oxidation of the gas coming from the gasification of the wood. This means you can reach the complete oxidation of wood at very low temperature. This is very important for NOx emissions, because we know that when you are burning wood, the temperature is so high that the nitrogen from the air is being oxidized to nitrogen oxides. And then you have to use a lot of chemicals to do the denox, or the reduction of nitrogen oxide. So there we use the technology which is actually preventing the formation of NOx. As I said, the power is 10 megawatts. We produce steam at 430 degrees and 30 bar. And all the steam which is manufactured in this technology is used directly in the production. So this plant is not operated like the coal power plant, where you're heating up the water, making the steam, use the steam for generate electricity, and then you have to cool down all the steam, and you have a lot of heat going into the cooling towers. In this system, all the steam which comes out of the turbine goes into the production. So the design of the plant is such that the energy plant is always following the demand of the production. It means that the production of the heat and power is fluctuating, and these dynamics can follow the dynamics of the production downstream. So it means we have overall extremely high efficiency, because there is practically no heat going to waste. So we are taking all the electricity and we are taking all the heat back. So the overall efficiency of the system is about 93%, which is, if you compare it to the nuclear, which is method how much? 33? Or thermal, maybe 55 or something like that. Yeah, it's 3 times higher. And this is where the efficiency, as I mentioned before, in the energy transition and the green transition, the focus has to be the efficiency. Otherwise, we will never reach the global goal that we have. So we like to say that Melamin made the green transition already 10 years ago. So this is the story which is in the distant past, actually, for the company. And we are focusing as a chemical plant, also for the future of the materials that we produce. We know that you can decarbonize power and energy, but you cannot decarbonize organic chemical production, because organic chemistry, you need carbon. There's no other way. And if you would read the Green Deal carefully, you would see that there is no Green Deal without chemical industry, because you cannot prevent all various industrial sectors and uses prevent to emit any kind of CO2. So there will be always emissions of CO2. And in the Green Deal, only sector that is responsible to take this emission out of the atmosphere is the chemical industry. So regardless of everything, at the end of the day, we will have around Europe and around the world, we will have a lot of chemical plants that will do carbon capture. And then this carbon as a CO2, liquid CO2 at the end, will be used to produce different kinds of materials. And this is just a very short presentation of our idea. So at the moment, we take, for the raw materials like methanol, we take the Russian gas or Algerian gas, whatever. We go into the refinery, we produce different kinds of polymers. When this is the end of life, we produce CO2. And this CO2 is captured by nature, by trees. And then you need 1 million years to make the loop again. So the problem with this loop is here that it takes 1 million years to transfer the biomass to natural gas. And we don't have 1 million years. We have to do a shortcut. Now our idea is actually to bypass the fossil resources and to use biorefinery as a technology to do this shortcut, and we can save 1 million a year here. So the idea in Melamin is to really develop the technology to be able to use biorefinery and to use captured CO2 in combination to produce, in our case, biomethanol, as it was presented by the deputy mayor in Estonia just a few minutes ago. And I think this will be the case of many communities where we will see very complex connection between solar and wind production of huge amount of electricity in the daytime. And then this electricity cannot be stored in the batteries or just the pumping power stations. So we will have to use it for hydrogen. Hydrogen is extremely difficult to store and very dangerous. So you have to transfer hydrogen somehow. And hydrogen with CO2 can produce methanol. And methanol is easy to store. It's a liquid, and it can be used as a fuel, jet fuel, or chemical, basic biomaterial for many different cases. So our idea for the future is the biorefinery that is part of the new plant location, because the biorefinery takes about 10 hectares space required actually to be built. Our idea is to use still local wood biomass up to 100,000 tons of dry biomass as a carbon source. We plan to produce hydrogen and oxygen on site from renewable energy resources. We don't have windmills in Chile. We don't have wind like in Estonia, but we have very good solar irradiation, so we have a lot of solar potential in the future. So we believe that very cheap electricity will be available in the future to produce hydrogen and use hydrogen and CO2 to produce methanol. And of course, the byproducts of the biorefinery is, as Deputy Mayor said, it's heat and power. So this energy can be used for many different industries from local communities. And of course, our idea is to produce biomethanol, about 60,000 tons, which is required for the company needs actually in the future. So just to summarize, in the case of Melamin, the energy part decarbonization project was done 10 years ago, but we are still a long way to go if we want to do the complete decarbonization and to change the industry from the fossil carbon resources to the renewable materials. Thank you.